All right, in this next section, we're going to be talking about how we can use the SSS and the SAS triangle similarity theorem to prove that two triangles are similar. So let's take a look at this first example. Is either triangle DEF, this triangle, or triangle GHJ similar to triangle ABC? This is basically telling us which one of these triangles is similar to ABC. So in order for us to do that, we're going to find out if all corresponding sides are proportional. So if all corresponding sides are proportional from one triangle to another, then we can assume that they are similar, okay? So let's take a look. We're going to compare these two triangles. I'm going to have over here triangle ABC, where the length of AB is 8, the length of BC is 12, and the length of CA is 16. And let's compare this first with triangle DEF. Okay, so triangle DEF from, if we want to compare this, let's see, D to E is going to be 6. EF, the length of EF is 9, and the length of FD is 12. Now let's compare all of these, okay? So it doesn't matter which way you go, but I'm just going to go from ABC to DEF. So if they're all proportional, so we'll compare the proportions. 8 over 6. So from AB to DE. If we were to simplify this fraction, it's going to become 4/3. So right away, we already have like a scale factor, or it's proportional. It's 4/3. Let's see if it's going to be 4/3 for everything else. So from BC to EF, it is going to be 12 over 9. And if we simplify this fraction, well, I notice that 12 and 9 are both divisible by 3. 12 divided by 3 is 4, and 9 divided by 3 is 3. So far, so good. It looks like that they are proportional. And then let's go ahead and do the last pair of the last pair of corresponding sides. The last one would be 16 over 12. I notice that 16 and 12 are both divisible by 4. 16 divided by 4 is 4, and 12 divided by 4 is 3. And notice here, they all have the same proportion, which is 4/3. If all corresponding sides are proportional, then they are similar. So what can we say? We can now say that triangle ABC is similar to triangle DEF. And make sure that all of these will be corresponding. A is corresponding to D, B to E, and C to F, okay? So far, so good. Triangle DEF is proportional. Let's go see if this is also going to be proportional to triangle GHJ. Okay, so again, I'm going to take this and I'm just going to copy it over here. Awesome. And let's compare this now to this triangle. So triangle GHJ. Okay, let's talk about all of these lengths then. So AB will be corresponding to GH. The length of GH is 8. BC will be corresponding to HJ. The length of HJ is 10. And then CA will be corresponding to JG, which is 16. Now let's compare all of these sides. All right, so from AB to GH, we have 8 over 8, and 8 over 8 is just 1. So far we have 1, and then from BC to HJ, 12 over 10. Oh, this is not going to be 1. This is going to be what instead? This is going to be 6 over 5. And it's already not proportional. And just for good measure, let's go see for CA to JG. Oh, 16 over 16, which is 1. So even though two side lengths are proportional, the third one is not. And by the SSS triangle similarity theorem, all three sides have to be proportional. So in this case, they are not similar. So triangle ABC is not similar to triangle GHJ. It's only similar if all three sides are proportional. All three corresponding sides are proportional, okay? Okay, that's it. Bye.